Okay, so there is this fascinating and honestly kind of alarming mystery unfolding in the Pacific Ocean right now. You've probably heard about the developing 2026 El Nino, right? People are saying it's breaking records. But as we're going to see in this explainer, the El Nino itself, that's really just the tip of the iceberg. The far bigger puzzle is what's actually happening underneath it.
To really get what's going on, we got to look at some new analysis from climate scientist James Hansen and his team. Now, if you follow climate science, you know Hansen. He's a physicist, former director of NASA's Goddard Institute for Space Studies, and he's basically been studying the climate for half a century. His 1988 Senate testimony is literally what helped put global warming on the public radar. He's known for being super independent and totally willing to challenge the scientific consensus when the data demands it. And right now, he and his team are pointing to 4 very specific graphs that outline an urgent scientific mystery.
So instead of just checking the surface temperatures, Hansen's team went deeper. Notice the red line here. That's showing the temperature anomaly in the upper 300 meters of the Pacific for this current 2025 to 2026 event. It is just surging toward a massive 3 degrees Celsius above average, blasting right past those legendary peaks we saw in 1997 and 2015. It's a spike so extreme, they're literally calling it a super-duper El Nino.
But we really need to make a crucial distinction here. A super-duper El Nino perfectly explains a temporary massive spike in global temperatures, right? It's just a natural movement of heat between the ocean and the atmosphere. However, it cannot by itself explain why the baseline temperature, the starting point from which that massive spike actually begins, just keeps rising. To understand that underlying trend, we have to zoom out and look at the whole planet.
And when we zoom out to look at the entire globe, this is from August 2026, the picture gets even more intense. You can easily spot that brilliant red streak of the El Nino right at the equator. But look literally everywhere else. Huge swaths of the world's oceans are covered in deep red and orange. This current El Nino isn't happening in a vacuum. It's developing on top of an ocean that is already completely packed with an unprecedented amount of accumulated heat.
And hey, this isn't just some abstract color coding on a map. This is our physical reality. This massive accumulation of heat translates to severe, prolonged marine heat waves. We're talking physically devastated coral reefs, displaced marine species, and completely upended global fisheries. And since the ocean dictates so much of our overall climate, an overheating sea directly alters the rain, the drought, and the severe storms over the land where we actually live.
Which brings us to the historical context. And this is where Hansen's main concern really hits home. For most of the 20th century, global surface warming was a steady, gradual climb, roughly 0.18 degrees Celsius per decade. But check out the steepness of the curve on the right side of this chart. Since 2010, that rate has nearly doubled, and since 2015, it's tracking even faster. It strongly suggests that global warming isn't just continuing, it's actively accelerating. Hansen uses a really great analogy for this. He says El Niños are like waves riding on a rising tide. A super powerful wave, like our super-duper El Nino, can make an individual year violently hot. But the wave itself doesn't explain why the tide is rising higher and higher. The ocean baseline is fundamentally hotter, which means every successive wave is crashing higher onto the shore. We need to know what is causing that tide to rise so rapidly right now.
So why is the tide rising so incredibly fast? Well, we have to look at the planet's energy flows. To maintain a stable climate, the solar energy Earth absorbs has to roughly balance out the thermal energy it emits back into space. But if you look at the bottom panel here, this is Earth's energy imbalance, or EEI, you see a very clear growing gap.
Think of Earth's energy imbalance like a giant planetary bank account. If your income matches your expenses, your bank account stays perfectly stable. But if Earth continuously absorbs more energy from the sun than it loses back to space, that excess energy has nowhere to go. It just accumulates as heat, which is mostly absorbed by our oceans. This imbalance is the undeniable physical driving force behind global warming. And the data we're getting from satellites and ocean floats, it's just staggering. Between 2000 and 2015, the average energy imbalance was around 0.60 watts per square meter. But between 2020 and 2024, that average leaped to roughly 1.25 watts per square meter. Earth's energy imbalance has roughly doubled. Now, I know 1.25 watts sounds tiny, but when you multiply that across the entire surface of the Earth, it equals about 640 terawatts of net heat. To put that in perspective, that's equivalent to exploding hundreds of thousands of atomic bombs worth of energy into our oceans every single day, hour after hour, day after day. Okay, let's pull all of this together. The physical reality shown across Hansen's graphs is pretty stark. 1. We've got unprecedented heat accumulation in the Pacific driving a super-duper El Nino. 2. That El Nino is sitting on top of abnormal, severe global ocean warmth. 3. The underlying trend of global warming appears to have significantly accelerated. And 4. The physical reason for this acceleration is a doubled Earth energy imbalance. And remember, this isn't some theoretical computer model. This is observed data from satellites and ocean floats.
So this 2026 El Nino, it's eventually gonna fade. They all do. But that doubled energy imbalance, that is sticking around. The tide is gonna keep rising. So the inevitable question we have to face as a society is, what do we actually do about that?
And this is exactly where the Healthy Planet Action Coalition, or HPAC, comes into the picture. HPAC is this international coalition of over 200 scientists, engineers, and policy specialists. They look at this accelerating energy imbalance, and they advocate for a unified three-part climate strategy: cool, reduce, and remove. They argue that all three are absolutely necessary if we want to stabilize our climate. Let's break those down. Reduce means aggressively cutting our greenhouse gas emissions, transitioning away from fossil fuels. Remove means actively pulling excess legacy carbon dioxide right out of the atmosphere. Together, reduce and remove address the absolute root cause of the warming. But the hard truth? That's going to take decades to achieve globally. And that is exactly why HPIC emphasizes the third pillar: cool. Cooling refers to temporary emergency measures to dial down the excess heat right now. It doesn't solve the underlying carbon problem, but it buys humanity critical time while the slower work of reducing and removing actually catches up.
To bridge that gap, HPIC points to something that is definitely controversial: sunlight reflection methods, or SRM. The basic idea is to deliberately reflect just a tiny fraction of incoming sunlight back into space. And yes, these methods carry significant environmental and political risks. Nobody is denying that. But HPIC argues that given the terrifying reality of that doubled energy imbalance we just looked at, we desperately need formal, highly governed research to understand these tools before the crisis gets even worse.
One specific method they really want to look into is called marine cloud brightening. So low marine clouds naturally reflect sunlight based on the microscopic droplets inside them. The hypothesis here is that by carefully spraying natural sea salt particles beneath these clouds, we could increase the number of droplets, making those clouds brighter and more reflective. Again, it wouldn't fix ocean acidification or remove carbon, but it just might provide a temporary cooling shield.
Now, get ready for a deeply ironic piece of this puzzle. For decades, commercial ships burned dirty, high-sulfur fuel. It was terrible for coastal air quality, obviously, but those sulfur particles actually brightened marine clouds, creating this massive, unintentional cooling effect that masked global warming. In 2020, new maritime rules rightly banned that dirty fuel to save human lives. But by removing the pollution, we accidentally removed our unintended cooling shield, allowing a lot more solar energy to heat the oceans. Now, HPAC wants to know if we can achieve that same cooling effect deliberately, safely, and entirely on our own terms.
So HPAC actually ran some preliminary numbers, and get this, they suggest it might only take about 20% of the sulfur that shipping used to emit before those 2020 rules to achieve substantial ocean cooling. And the key difference? Instead of dirty commercial ships polluting heavily populated coastlines, this tiny fraction would be distributed very thinly using specialized unmanned surface vessels far out in remote ocean areas and only under very specific meteorological conditions.
Because of all this, HPAC is actively requesting a tightly controlled research exemption from the IMO's sulfur rules. To be clear, they are not asking to bring back commercial coastal pollution. No way. They're just asking for permission to run carefully governed scientific trials using special-purpose climate research vessels far away from humans. They just want to test the hypothesis. Can marine cloud brightening safely and effectively help reduce dangerous ocean warming? But so far, they're actually struggling to get regulatory permission to even conduct the research. HPAC firmly believes that while governments shouldn't just assume this will work, they absolutely shouldn't refuse to find out.
If James Hansen's data on that doubled energy imbalance is right, the tide of heat is rising way faster than our current efforts to lower emissions can handle. We really have to ask whether we can safely cool the planet while we fix the underlying carbon problem. You can find links to Hansen's research and the HPC Coalition in the description of this explainer. Definitely hit like and leave a comment below to help push this vital discussion forward. But I want to leave you with this one thought. If the house is already on fire, do we really have the luxury of refusing to test the fire extinguisher just because we're afraid of the foam? Think about it.